Hello friends, welcome to my channel Vaira Citadel. In the last three videos, we saw how to solve coding problems, both with numbers and coding problems with letters. Now today in this video, we will see questions based on series. Well, what is a series? Series is a sequence. It may be a sequence of numbers, or it may be a sequence of letters, or maybe a mix of both. And they are arranged in a definite pattern. So that is a series. Before getting into problems, we will see the basic types of numbers. You know that there are various types of numbers like natural numbers. Natural numbers, it starts from 1 and it goes on like that, 1, 2, 3, 4, 5, infinite. And whole numbers, what are whole numbers? It's the same as natural numbers, 1, 2, 3, 4, 5, but it includes 0. But natural number, 0 is not included. Whole number, you start from 0 and it goes on infinite. And then you've got even numbers. As you all know, even numbers are divisible by 2. 2, 4, 6, 8, 10. And then odd numbers, they cannot be divided by 2. 1, 3, 5, 7, 9, 11. And finally, prime numbers. What are prime numbers? They are numbers which are divisible only by itself and 1. They can be divided either by the same number or by 1. That's all. They have no other divisor. See, now there are different patterns, different types of questions asked in number series. We will see one by one. Look at the first problem. And in all these problems, again, you have to find the pattern. Pattern. So find the pattern first. And in the same pattern, find out what the number should follow in the series. And usually the clue, I'll give you one clue that if the numbers are increasing, continue. But first to see if the numbers are increasing or decreasing. See, in the first case, see here, in the first case, the numbers are increasing. 3, 6, 9, 12. It is increasing. And see, look at the second problem. 30, 25, 20, 15, 10. It is decreasing. So if the number is increasing, it could be addition or multiplication. And if the numbers are decreasing, then it could be subtraction or division. And again, when the numbers increase, if they increase continuously very fast, that means it is multiplication. See here, 3, 6, 12, 24, 32. So the increase is very fast. So that means it is multiplication. And here 3, 6, 9, 12, it is slow. So if the increase is slow, it is addition. The same way in the case of subtraction and division. If the decrease is very slow, it could be subtraction. And if the decrease is very fast, then it is division. Now look at the first one. And all these problems are very simple. What I have given is for you to understand the basics. You need not draw the table. You can just by looking at the numbers, you can find out what is the pattern. But suppose if you are not able to do it, always you can draw the squares. And see here, so as usual, I'm sorry, I'm not getting it. Okay, doesn't matter. So write the number here on the top row. And it is 3, and see the next number is 6, and the next number is 9, and the next number is 12. So how does this 3 become 6? Addition of 3. Put the number, the change 3. 3 plus 3 is 6. And how does this number 6 becomes 9? Again by addition of 3. And how does the number 9 becomes 12? Again 3. So the constant number, here the increase is by 3, which is a constant number. So what should be the next number? 12 plus 3 is 15. So all these things you can do it just by seeing the number. They are very small numbers. You can just do it mentally and find out the last number in the series. So 12 plus 3 is 15. Or else you can also, if you want, draw the square with 2 rows, with the upper rows then with the numbers given, and in the lower rows put what is added or what is subtracted, and you will, if you are not able to do it, mentally. And then coming to the second problem, see here 30, 25, 20, 15, 10. And as you, it is also very simple. It is just minus 5. So all the numbers are derived by subtracting the number 5. So 30 minus 25 is 5, 25 minus 5 is 20, 20 minus 5 is 15, 15 minus 5 is 10. So 10 minus 5 is 5. So the next number in the series is 5. If you find it difficult doing it mentally, you can draw the squares, 2 rows, the upper rows with the given series of numbers right here, 30, 20, 5, 20, 15, one more column, you draw it. And see how does this 30 becomes 25 minus 5. It becomes 25. How does this 25 becomes 20 minus 5? So you see the decrease is by a constant number 5. So I'm just showing it with the table because if you find it difficult to do it mentally, otherwise it is not at all required. And the next in the series, see 3, 6, 12, and here is the increase. So it should be multiplication or addition, and the increase is very fast. 3 becomes double and 6 becomes 12, again double and again double. So it is multiplication by a constant number 2. So what should be the next last number in the series? 32 into 2, it is 64. And in the same way, this problem, the first number is 1000 and the second one is 500. Just to see how do we get 500 from 1000? Only if you divide it. So when will 1000 become 500? If you divide it by 2. So again 500 divided by 2, 250. 250 divided by 2, you will get 125 is the answer. So this could be as simple as that. That is increase or decrease or multiplication or subtraction by a constant number. Alright, these are all very simple questions. You can do it. So far we have seen the problems with addition or multiplication or subtraction or division with a constant number. Very easy. But now we are seeing a problem in which the numbers are increasing, and I told you it could be addition or multiplication, but they are not by adding a constant number. See, 10 has become 11, addition of 1. But 11 has become 13. It is addition of 2. So you should find out the pattern here. the pattern by which the numbers are added. So that is again, there is not a constant number used, but there is a pattern in the numbers used for addition or subtraction, and you have to find the pattern and apply the same pattern to the last number in the series. So you better draw a table with 2 rows with writing all the numbers in the series in the top column, and in the lower column you find out the difference. The difference between 10 and 11 is +1. So put the difference below. And what is the difference between 11 and 13? It is +2. And what is the difference between 13 and the 16? You find the difference between the two consecutive terms. And the 13 and the 16, the difference is +3. And you know what is the pattern here? +1, +2, +3. And the next number should be +4. Got it? So that is the pattern. The numbers are added sequentially by adding one more number. +1, +2, +3 and +4. If you add +4 to 16, you will get 20. So what is the next number in the series? 20 is the answer. In the same way for subtraction, the numbers in the series are 30, 25, 21, 18, 16. Put them on the top row of the table you draw and find out the difference between the two consecutive numbers. How does the 30 become 25? By -5. Right here, -5. And how do you get 21 from 25? By subtracting 4. And how do you get 21 from 25? By subtracting by the number 3. And how do you get 18 from 28? By subtracting 2. And now what should be here? Find out the pattern. Again, -5, -4, -3, -2. Then it should be -1. So what is 16 minus 1 is 15. So the next number in the series is 15. That is your answer. So this slightly advanced version of the same addition, multiplication, division and subtraction, but it is not by a constant number. There is a pattern. The same way for problems in multiplication and division. So here the number is increasing 5, 15, 30, 90, 180. So it is increasing fast. The 90 has become doubled. So it could be multiplication or addition, but here it's going very fast. So that means a multiplication. So draw the table. On the upper row, you write the numbers in the series 5, 15, 30, 90, 80, and you derive how does this 5 become this 15 if you multiply it by 3, and how does 15 become 30 you multiply it by 2, and again 30, how does it become 90? By multiplying by the number 3. And how does this 90 become 180? Multiplying by 2. And see here, there is a pattern. The multiplication is by 3, 2, 3, 2. Then what is the number in the series? 3. So you are multiplying in your sequential order. First by 3, then by 2. Again by 3, then by 2. Then again it should be 3. 3, 2, 3, 2, 3, 2, 3, 2. So if you multiply 180 by 3, you will get 3, oh no, 0, 27, 2, 3, 5, 570. Am I right? So if we 570. Okay. So the next number in the series is 570. So again, this is a pattern. It need not be multiplied by 3, 4, 5, 6, 7. It could be in the order, or it could be a repetition of 3, 2, 3, 2, 3, 2. So you have to find out looking at the pattern. And coming to the next problem, it is 1 lakh has become 10,000. and that has become 2000. You write the numbers on the top in the same way. And how do you get this? So find out what is the difference. How will you get this number from this? So only if you divide it. I told you the lesser the number, if it is decreasing, that means it is division or subtraction. But here 10,000 is derived from 1 lakh. So it is such a huge difference. So it should be division. So one number is cut off. So what does it mean? It is divided by 10. And now the difference. Look at the next two numbers in the series. 10,000 has become 2,000. How does it? What has happened? It is divided by 5. Now 2,000 has become 200. So what is the divisor? It is divided by 10. So the 200 has become 40. What is the divisor? 5. So look at the pattern 10, 5, 10, 5, and what is the next number in the series? 10. You've got to divide it by 10. So 40 divided by 10, you will get the answer of 4. That is the answer. See, in these type of questions, you see squares of numbers, not just addition or multiplication or division or subtraction, but you see squares. See the number 9, 16, 25, 36. So by looking at this, you should know they are squares. So 9 is 3 square is 9. What is square? Multiplied by the same number. 3 into 3 is 9. In the same way, 16 is 4 into 4 is 16. And 25 is 5 into 5 is 25. And the number 16 is 16 into 6 squared. That's what we say, 6 squared is 36. So this is how we derive the next number in the series. So this is 3 squared and this is 4 squared and this is 5 squared and this is 6 squared. And what should we get? The next number should be 7 squared. See the pattern? So 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. What is 7 into 7 is 49. So the next number in the series is 49. Got it? And now coming to the next problems. It may be cubes also. So see, look at the numbers in the given, the problem 0, 1, 8, 27, 64, always 27, 64, it is cube. What is cube? The same number multiplied 3 times. See, 0 into 0 into 0, you get 0. And 1 into 1 into 1, you get 1. 2 into 2 into 2, you get 8. 2 in 3 times, cube is 3. 2 into 2 into 2. 2 into 2 are 4, 4 into 2, 8. And in the same way, 3 into 3 into 3, 3 into 3 are 9, 9 into 3, 27. And 4 into 4 into 4 is equal to 4 into 4 are 16, 16 into 4 are 64. Now look at the pattern. 0 cube, 1 cube, 2 cube, 3 cube, 4 cube, and the next should be 5 cube. So 5 into 5 into 5 into 5. 5 into 5 is 25. 25 into 5 is 125. Right? So the answer is, the next number in the series is 125. 25. Is that clear? Good. Now, look at the next problem. 17, 19, 21, 23, 25. Always read the entire numbers once or twice. Then you will get the pattern immediately. And if you don't get it, then draw the square. See, look at the number 17, 19, 21, 23, 25. Anybody who is, the average proficient in mathematics, arithmetic will know that the difference is 2, 2, 2, 2. They are the odd numbers. 17 plus 2, 19. 19 plus 2, 21. 21 plus 2, 23. Plus 2, 25. Or if you're not getting it at the first sight, then draw the table, write the numbers given on the top row, find out the difference between the two consecutive number, all the numbers. So you will come to know they are all 2, 2, 2, 2, 2, 2, 2 added. 2, the number 2 is constantly added to all the numbers. So what will you get by adding 2 to 25? You will get 27. So the answer is 27. The next number in the series is 27, which is again a odd number. That means which is not divisible by 2. And here read out the next problem. 64, 66, 68, 70, 72. Again, there is a constant difference of 2. Addition of 2. So the next even number. So you can just by looking at the numbers, you can write it is 74. Or if it is not possible for you, draw the table. If you are very poor in arithmetic, draw the table, write the numbers 64, 66, 68, 70, 72 and find out the difference. Here, how does 64 become 66? 2 by adding 2, by adding 2, by adding 2. Then add 2 here, the last number, you get, if you add 2 to 72, it becomes 34. Now, the next is 1, 3, 5, 7. So, looking at the number, you can say they are prime numbers. At least up to 13, you learn the prime numbers by heart. 1, 3, 5, 7, and the next number is 11. Why? Because 8 is divisible by 2, 8 is divisible by 4. So it has got more than 2 divisors. Then it is not a prime number. A prime number has got only 2 divisors. One is the number itself and another is by 1. So if they have got only 2 divisors, then it is called a prime number. Because 7 is a prime number because it can be divided only by 7 or by 1. Nothing else. It cannot be divided by 2, it cannot be divided by 3, not by 4, not by 5. But 6 on the other hand is not a prime number. Why? It can be divided by 1, it can be divided by 6, and it can be divided by 2, and it can be divided by 3. So it has got 4 divisors, so it is not a prime number. And in the same way, 4. 4 is not a prime number because 4 can be divided by 1, 4 can be divided by 4, and it can be divided by 2. So it has got 3 divisors. So it is not a prime number. Again, 8 is not a prime number because 8 can be divided by 1 and 8 can be divided by 8 and it can be divided by 2, it can be divided by 4. So it has got 4 divisors. So 8 is not a prime number. And again 9 is not a prime number because 9 is divided by 1, 9 is divided by 9, it can be divided by 3. So it has got 3 divisors. 10 definitely not a prime number because 10 can be divided by 1, 10 can be divided by 10. and it can be divided by 2, it can be divided by 5. So it has got 4 divisors. And 11, that is when doing the division, you should not get any remainder. The remainder should be 0. That is what we say. Okay. When we say divisor is by the number by which if you divide it, you will not get any remainder. And the number 11, it cannot be divided by 2, it cannot be divided by 3, it cannot be divided by 4, it cannot be divided by 5. It can be divided by only by 1 and by 11. So it's a prime number. So what is the answer? The answer is 11. So the next number in the series is 11. See, the next type of problem is using arithmetic progression, or also known as AP series. So look at the problem here. In a series 2, 4, 6, 8, what will be the 50th term? So here we see the series and we know it is increasing by a constant number 2. But what will be the number 50th term? So it's such a big number, you cannot write up to 50, 2, 4, 6, 8, 10, 11, 12, 14, 16 like that up to 50th term. You cannot keep on writing, it will take a lot of time. So but here, as we know, the numbers progress arithmetically. Like the first term is A, and then the second term is A plus D, and the third term is A plus 2D, and the fourth term is A plus 4D, where A is the first term. You should know the formula. Okay, you have to learn the formula by heart. A is the first term and D is the common difference between the two consecutive numbers. So A is the first term and D is the common difference. How do you find the common difference? You find the difference between any two consecutive numbers. That is, you can find the difference between 8 and 6 or 6 and 4 and 4 and 2. The difference is 2. So what is the first term? 2. D is also 2. Now, see this formula. The term 1, how do you find out the nth term? Nth term is Tn. The first T1 is first term, T2 is second term, T3 is third term, and T4 is fourth term. And how do we find out? First term is A plus 1 minus 1 D is equal to A. And what is the second term? A plus 2 minus 1 D. That is equal to A plus D. Because 2 minus 1 D is 2D minus 1D. That is D, A plus D. And T3 is equal to A plus 3 minus 1 D. That is equal to A plus 2D. In the same way, if you write for nth term, so n we are going to replace it by 50. Okay, nth term is A plus n minus 1 into D. So replacing this for our given problem, we have the T50, the 50th term is equal to A plus, A is here 2. We have found out the first term is 2 plus n minus 1. What is n minus 1? N is 50. 50 minus 1, 49. Into D. What is D here? 2. So first remove the bracket. 49 into 2 is 198. Sorry, 98. 49 into 2 is 98. Plus 2 is 100. So the 50th term is 100. So you have to know this formula. nth term. T is equal to A plus n minus 1 into D. You have to learn this formula for arithmetic progression series, AP series. See, in the last problem we saw arithmetic progression, AP, where the number increases by A plus D, A plus 2D, A plus 3D, A plus 4D by common term D. And in geometric progression, the number also progress geometrically, like A becomes AR and AR becomes AR squared, then that becomes AR cubed, then AR raised to 4 times, then AR raised to 5 times. You know, they increases by the powers. So here also A refers to the first term and there D refers to the common term, and here R refers to common factor by which it is raised. How do we find out R? In the same way there D we found out by finding the difference between the two consecutive terms. Here we are dividing two consecutive terms. T4 is divided by T3 or T3 is divided by T2 or T2 by T1. You will get the same factor, common factor. So look at the number 4, 8, 16, 32 and divide, you can use any numbers, you know, the first term or second term. Divide the second term by the first term, you get 2. Or divide the third term by the second term, 16 by 8, you get 2. Or divide the fourth term by third term, you get 2. So the common factor R is 2. And the formula here is T nth term. Nth term is equal to A into R raised to n minus 1 time. How do we get this formula right for the first term? T1 is equal to A R raised to 1 minus 1 time, that is equal to A. And the second term is equal to T2 is equal to A R raised to 2 minus 1 times, that is equivalent to AR. And term 3, T3 is equal to A R raised to 3 minus 1 times, that is equivalent to AR squared. The same way for the fourth term. And if you substitute this for the nth term, you get A into R raised to n minus 1 time. So this is the formula you have to learn by heart. I now will come to the problem. So what is the nth term? What is n? N given here, this is the 10th term. We have to find out the 10th. So T10. The 10th term is equal to A into A is here. What is the first term? 4. What is R here? R is 2. Dividing the two consecutive terms, we get 2. So R is 2 raised. How many times you have to raise it to n minus 1? What is n? 10. 10 minus 1 is 9. 2 raised to 9 times. 4 into 2 raised to 9 times. So this is 4 is 2 raised to 2 times. And so 9 plus 2, 11. So 2 raised, the answer is 2 raised to 11 times. Because if you are multiplying it, the power you have to add. 9 plus 2 is 11. 2 raised to 11. Okay friends, we have come to the end of the video. And we have learned how to solve problems in number series, the various types, simple types using adding or subtracting, multiplying or dividing using the common number or by using a pattern, and how to solve problems in AP series, arithmetic progression series, and also in geometric progression series. What is the difference? And you've learned the formula, and you have to learn the formula by heart. No other go. I hope this is useful to you. And if you have not subscribed upon Vaira Citadel, which is catering to the needs of the UGC-NET crackers, please do it right now. And I'll see you in the next video. Until then, bye bye.